Look around you. What do you see? A concrete jungle is what the majority of us are used to seeing these days. It's very rare to find cities that have buildings constructed from much else. Concrete is a useful material, but is it possible for us to be free from concrete? This is Materials Lab, and will we ever be free from concrete? After water, concrete is the most widely used substance on Earth. The Romans use it in their construction projects, even the Colosseum. Eventually, concrete as we know it today was introduced. Reinforced concrete was pioneered in France in the mid-19th century. Without reinforced concrete, we wouldn't have these metropolises of concrete. But now, we need to seek alternatives, as concrete is similar to plastic. And just like plastic, it was a ticking time bomb causing environmental damage everywhere. The cement industry is responsible for about 8% of global carbon dioxide emissions, more than double those from flying or shipping. More than 4 billion tons of cement are produced each year to build houses, motorways, flood defenses, and more. So, what options do we have? The first is Ferrock. This material is composed of waste steel dust and silica obtained from ground-up glass. Ferrock was discovered completely by accident by David Stone. He was attempting to keep iron from rusting and hardening up. Initially, Stone discarded this incredibly hard material, then realized it might have a useful purpose compared to concrete. This unintentional material is 5 times stronger than Portland cement, and it is very strong and flexible, meaning it can bend without breaking due to seismic action. A fantastic feature not found in many other materials is that Ferrock becomes even stronger in saltwater environments, making it ideal for marine-based construction projects. Lastly, Ferrock is beneficial in lowering CO2. As it dries, Ferrock absorbs and binds CO2. This results in a carbon-negative process that helps to trap greenhouse gases. Its production generates a lot less carbon dioxide than concrete. Another similar material, ashcrete, is made from waste fly ash from coal-burning operations and has similar characteristics as Ferrock. About 93% of the resulting substance is made of recycled material, making it immediately more environmentally viable. Fly ash is the main component of ashcrete. It is used to replace cement in the concrete mixture. Similar to volcanic ash, fly ash reacts with calcium hydroxide in the presence of water to produce a strong, sturdy material that is stronger than regular cement. However, fly ash is produced by the burning of coal, which means CO2 would still be produced. However, the amount of CO2 emitted from 1 ton of fly ash would still be less than that produced during the manufacture of 1 ton of cement by a significant factor. Next is hepcrete, which is a biocomposite material. It lacks the brittleness of concrete and consequently does not need expansion joints. It is a lightweight, insulating material suited for most climates. Hepcrete has been around for a while, first being used during the early 1990s. It is made from mixing hemp hurd with lime and water and weighs only about 1/8 of regular concrete weight. It can breathe and allows moisture to evaporate and is avoided by termites. The non-toxic and lightweight properties of hepcrete also ensure it is easy to move around a job site. A material you may never have heard of is next, mycelium. Mycelium are the thin, root-like fibers from fungi which run underneath the ground. Once dried, it can be used as a tough, water, mold, and fire-resistant building material. It can be grown into specific forms. Lastly, there is a material called phenite. It is made from readily available desert sand, a resource that has ultimately been useless for building until now. Desert sand has no uses as its grains are too smooth to bind together. Concrete produced from desert sand is too weak to use. The scientists from Imperial College London that created phenite believe that it outperforms concrete on key suitability metrics. For now, the binder ingredients are a guarded secret, but it is non-toxic and can be left to decompose naturally or remolded to be used in another project. Most people think concrete has a huge impact on the environment, and they are right. But concrete has that impact because it's the most used material, says Jorge de Brito, University of Lisbon. So, we have multiple materials to choose to construct our buildings from in the future. Would you feel safe living in a skyscraper constructed from an alternative material to concrete?